Okay, so we can move to the 12th question. So for the given unit cell of two-dimensional square lattice, which option lists all the primitive unit cells? So we have the five different unit cells are shown in this figure for a square lattice. So the first three and fourth one is basically a square lattice, and second one is an oblique lattice, and fifth one is a rectangular lattice. So which of these options or which of these are the primitive unit cells? That is the question. Okay. So what is meant by primitive unit cell? So primitive unit cell are the unit cell which is having the total effective number of lattice point 1. Okay, so obviously if you look at the lattice 1, the lattice 1 is basically a primitive lattice because it is in the shape of square, and the lattice points are present only at the corners. So effective number of the contribution of one lattice point to one of the uh, unit cell is only 1 by 4. So the contribution is 1 by 4, and we have 4 such corners, so the total it will be 1. So this is an example for primitive unit cell. What about 3? It is also an example for primitive unit cell because it contains only one lattice point inside. The 4 also contains one lattice point inside. And second, again, effectively it contains only one lattice point because it has 4 corners. So effectively it has one lattice point. But the fifth one is not primitive unit cell because it has 4 corners, so its contribution will be 1. Plus there is a contribution from the edge as well. So this edge, it has 1 by 2 contribution. This also 1 by 2 contribution, so it has 1 contribution. So the corners have 1 contribution plus edge has 1 contribution. So total contribution of lattice point will be 2 for the option 5 or for the choice 5. So only 1, 2, 3, and 4 are primitive unit cells, so which is the correct option. So the C is the correct option. Okay. So next we'll go to the last question. So the third nearest neighbor in a BCC crystal with a lattice constant A0. The third nearest neighbor. So we have to find out the third nearest neighbor in BCC lattice. So we can just draw the BCC lattice first. So BCC lattice, which is having lattice point at all corners plus this lattice point at the center as well. Okay. So if you look at the center, so the center can be treated as the origin. So which is the nearest neighbors for the center. So if you look at the center, so each and every corner would be nearest neighbors. Okay. So the first nearest neighbor, which is the corners, which is at a distance uh, r, or it would be equal to r is basically how much would be that, okay, not r, it is equal to 2r. So in terms of the lattice parameter a, it will be half of the body diagonal, so it will be root 3a by 2. Okay, so which is the second nearest? How to find that? I think in order to find the second nearest, instead of looking from the center, so better look from one of the corner. So if you look from one of the corner, the first nearest neighbor is this, the first nearest neighbor. The second nearest neighbor would be the next corner. So this would be second nearest neighbor. It is at a distance a lattice parameter. And then who will be the third nearest neighbor? The third nearest neighbor would be the base diagonal. And it is at a distance root 2a. So the answer is this, root 2a, third nearest neighbor. Okay, so there are some questions related to it as well. So we can have we have discussed the first nearest neighbor, which is the closest neighbor. Now the number of first nearest neighbor is called coordination number. So in case of BCC lattice, if you take this as your reference, then all these corners are the first nearest neighbors. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 nearest neighbors. So the coordination number is 8. So for BCC, the coordination number is 8. And if you go for symbolic cubic, the coordination number would be 6. And for face-centered cubic, how many would be there? So I think it is 12. The 12 nearest neighbors are there. So the coordination number would be 12. So the coordination number for symbolic cubic system, we have 6. For body centered, we already calculated this 8, and face centered cubic it is 12. And body centered we already written. Body centered cubic system is called coordination number. It is the number of nearest neighbors. Okay.